Good evening, students. Today's session we are going to discuss about the liquid level control system. Okay, so in the first unit you are going to discuss about the process. Okay, so one of the process is nothing but the level control system. Okay, so let us explore what is that. Okay, yeah. So when you want to explore about the level control system, always you are going to consider the tank with the connecting pipelines. Okay. So the flow through the pipelines may be either laminar or turbulent. Okay. I hope you have studied this in your physics. The flow may be either laminar or turbulent, and that is determined using a Reynolds number. Okay, and it is very clear that if Reynolds number is greater than 3000 to 4000, the flow is turbulent, and if it is less than about 2000, the flow is laminar. Okay, for this let us assume that the flow is laminar, and we'll proceed with learning about this, exploring about this liquid level control system, right? So when you take this respective control system block diagram, you can see that as I said, it is going to have a storage tank with a connecting pipelines. Okay. Okay, so let us take this as a tank whose level is H. Okay, whose level is H, which is a parameter you are going to model, and you are going to thereby you are going to control. Okay, and you can see that there is a inflow rate, that is Qi. Okay, and the respective output is a Q naught. Okay, and the capacitance of the particular tank is C, and there is a valve connected at the outlet of the pipeline. Okay, this valve is associated with the resistance. Okay, so let us explore about these parameters right now. Okay, so it is very clear that you are going to have a inflow rate Qi, outflow rate Q naught, capacitance C, resistance R, and the respective level you are going to model it is a H. Now let us define what is this resistance and capacitance. Okay, it is similar to electrical system. The resistance you call it is a laminar flow resistance, and the capacitance you call that as a laminar flow capacitance, being the flow through the pipeline is a laminar. Okay, so if you take a resistance, it is defined as a change in the level difference to the change in the flow rate. Okay, so always the resistance is represented as H divided by Q, and you call this as a laminar flow resistance, which is analogous to the electrical resistance. Coming to the capacitance, okay, this is called laminar flow capacitance. It is represented as change in liquid stored to change in head. Okay, so it is obviously the storage capacity of the particular tank. You define that as a capacitance, and it is nothing but the area. If you see this unit, it is meter cube by meter, which is represented as meter square, which is representing the cross sectional area. Okay, and the capacitance is constant for any head. Okay. Coming to the mathematical model of the liquid level control system. So when you want to model the particular system, you need to write the mass balance equation governing the particular system. Okay. So as I already discussed, let us see the Q bar is the steady state flow rate. Let us take small Qi is a small deviation of the inflow rate from its steady state value, whose unit is meter cube per second, and respect to Q naught is the outflow rate. There is a small deviation of the outflow rate from the steady state value, and its unit is also meter cube per second. And H bar is a steady state head, and respect to H, small h is a small deviation of head from the steady state value, whose unit is m. Okay, now we are assuming the flow through a pipeline is a laminar, and let us represent the mass balance equation governing the particular system as C into dH is equal to dH by dt is equal to Qi minus Q naught. Let us say this Q naught is represented as H by R. From this you can just substitute this Q naught here, so you will get, instead of Q naught, you represent that as H by R. Okay, so that H by R will come, this left hand side will become plus H, and if you take LCM, you will get RC into dH by dt plus H is equal to R into Qi. Okay, so once you simplify the same equation, so in order to arrive the transfer function mathematically model, in the sense you are going to arrive the transfer function of the particular level control system. To arrive the mathematical model, to arrive the transfer function, we'll be taking the Laplace transform on both sides. So if you take a Laplace transform, you will get RC into S plus 1 into h of s is equal to r into q of s. Okay, so from this h by qi, okay, so h by qi is nothing but r by rcs plus 1, and already we know that h by r is nothing but q naught. Okay, so q naught by q naught is nothing but the outflow rate, and qi is the inflow rate, which is represented as 1 by tau s plus 1, where tau is a time constant which is represented as r into c. Okay, thank you, students.